I'd like to introduce Donald Farmer, Principal Program Manager for the Microsoft Corporation. Donald, you now have the floor.
Thank you very much. So welcome to this morning's webcast on building a simple recommendation engine with SQL Server 2005 data mining. It's an interesting subject, and we're going to show quite a few demos during this presentation. And one of the things I do want to emphasize is that we're building a simple recommendation engine in this case, not a full-featured one. But I do hope this will give you an opportunity to get started with some of the most interesting aspects of data mining, and one of the aspects of data mining that your customers may actually find most useful when you're getting this in action. So what we're going to cover today is, first of all, a brief overview of what recommendation engines are, why they're interesting, and why you should be interested in them. We're going to talk about preparing data for the recommendation engine, which is a very important step of any data mining process. We're also going to talk about how to build and train and test the data mining models. So we're going to walk through the creation and testing of a data mining model from scratch all the way through with SQL Server 2005 analysis services. We're going to cover a specific feature of SQL Server data mining that I think may be of interest, a feature called nested tables, which are particularly powerful for the kind of scenarios that we're going to be showing today, and which are actually quite a unique feature of SQL Server data mining, something that we find is particularly useful in these scenarios, but also is something which other data mining tools have typically struggled with. We're also going to show very briefly how to create a web-based client for SQL Server 2005 analysis services that will be able to talk to and query the recommendation engine. I do want to stress that although we'll be developing this web-based client in an ASP.NET app, this session is not primarily about how to develop ASP.NET web pages. It's really about developing this recommendation engine. So with that, we should talk a little about the prerequisites for the session. In terms of the hardware and in terms of the software that you'll need, we are talking about SQL Server 2005. Best to have SP2 installed. You can build this demo using Standard or Enterprise Edition. There are some limits in Standard Edition, but it's unlikely that you'll meet them in building this demo. There are some attribute limits, for example. I think you're limited to something like 5 million attributes in Standard Edition. Enterprise Edition, of course, is far more full-featured and enables even greater scale than you can in Standard Edition. You should install the RDBMS system, the SQL Server database, integration services, and analysis services. When you install analysis services, you will have the SQL Server data mining. Now, integration services I always suggest installing along with data mining because integration services is pretty important for the data preparation phase of your data mining. Now, we're not going to be showing much of that today. In fact, we probably won't show an integration services demo. But typically, using integration services to do your data preparation before data mining is a very, very useful first stage to make sure that you have the data that you want, that it's in the right format that you expect, that you've cleaned up the data, and so on. We're also going to use Microsoft Visual Web Developer 2005 Express Edition. I'm using Express Edition here because it's a nice lightweight tool for building this demo with, but of course you could also use the full version of Visual Web Developer or the web development tools available with C# or Visual Basic.NET. Today's sample is going to be built in Visual Basic.NET, but it could just as easily be built, say, in C#. So I think that pretty much covers the prerequisites. One thing I do want to stress is that we expect some familiarity with these tools, but we're not looking in this sample for deep knowledge. You don't need to be an expert in SQL Server or an expert in developing ASP.NET web pages, for example. So with that, I think it's time to talk about what the recommendation engines are. The simplest recommendation engine, as you can tell from the photograph, is typically the guy in the fast food store saying the classic line, "Do you want fries with that?" Having bought a burger, bought some Coke, the next thing is offered as well, based on those purchases that you've already made. Perhaps you'd like this additional purchase. You'd like fries, or you'd like some other side dish. The point about this being that the recommendation engine is taking a sample, if you like, of the goods that you've bought, and based on those goods that you've bought, is offering you something else, and we call that cross-sell. They may also offer you something upsell, what we call upsell. So for example, you go into the fast food joint and they offer you not so much do you want fries with that, but do you want to upsell this to a super value meal or whatever they may call the kind of upscale options. In that case, we call it upsell. So based on the items that you've bought, is there something more expensive, more valuable that we can sell you? Now, the recommendation engine in these cases is typically the clerk who's serving you in the food store. But of course, there are other examples of recommendation engines which we come across every day, and one of the most familiar ones is from the online bookstores, which say, well, customers who bought this book also bought this book. Would you be interested in these other books? And these recommendation engines can be very powerful as tools for bringing people to your website and offering them additional purchases. They can also be really useful to the end user. I personally nearly always explore these site tracks and find other books which I may not have thought of buying or may not even have known about, but they turn out to be interesting in that scenario. So a recommendation engine is essentially an automated way of providing that service to your users. Now, when we talk about recommendation engines, it's interesting to think about how these work. The typical scenario that we talk about is called market basket analysis, and you may well be familiar with this phrase. It really means that based on the goods which are in your basket, if you like, whether it's a virtual basket or a real basket, let's recommend something else based on those purchases. Now, one of the most important things about market basket analysis is that it's typically driven by the customer behavior, not by the business rules. Now, what I mean by that is, for example, if you have a very small set of customers, and I think back to the very first days of some of those online bookstores, I may have very eclectic tastes in books. So I may go in and buy a book on Chinese cookery and a book on data warehousing. The very next customer who looks at a book on Chinese cookery may well be offered, well, customers who bought Chinese cookery for beginners also bought data warehousing for experts. Clearly, that recommendation, in a sense, doesn't work. But one of the most important things about market basket analysis is that rather than saying, hey, we understand the user's behavior, we understand what our customer's doing, so based on some insight to our customers, we're going to provide recommendations. It's actually driven by the customer behavior itself, and we simply say, this is the truth of the matter. The customer who bought Chinese cookbook also bought data warehousing, and present that. Now, one of the most important things about market basket analysis is that with a very small number of users, you will get those anomalous answers. But as you add more and more cases to your scenario, as more and more people come online and start buying your goods and start making these purchases, then you'll start to see the patterns emerging and these very important rules emerging, which frankly will make more sense and be more useful to your customers. So in a sense, recommendation engines improve the larger the scale that they're working on. And so those very large scale cases can be very powerful indeed. So with that, I'd like to start showing you a recommendation engine in action. And this is a recommendation engine we're going to build today. So with this, I'm going to just drop out to a demo and share my application. And this is a little recommendation engine for recommending movies that we've just built. Now, if you'd like to see this recommendation engine in full screen, click F5 and you'll see the full screen view of the shared interface. Now, this demo was built originally by Jesper Lund and Roman Iyer from the SQL Server data mining team, and I'll give you a link at the end to where you can download their article and their code samples and so on for building this. But let's see the recommendation engine in action first. I have a little text box here, and in this text box I can enter the name of some movie that I want to buy. This is actually based on a movie database. So let's just enter here, Godfather Part 2, and you'll become familiar with these examples as we walk through them later on. I'm going to add this item to my shopping cart, and when I add the item to the shopping cart, the recommendation engine comes back and say customers who bought Godfather Part 2 also bought Godfather Part 3, The Godfather, and Star Wars. And so this is an interesting case for me to go out. I can say, okay, well, if I enjoy Godfather Part 2, maybe I'll enjoy Part 3 and The Godfather, the original. Similarly, I can have a look at the Matrix and say, okay, let's add that to my cart. And then it tells me customers who bought this movie also bought Star Wars, A Beautiful Mind, and The Empire Strikes Back. So that's the classic recommendation engines. Based on something that I've purchased, I can tell people what others have purchased, what other items may be of interest to me. It's a very simple demo, but this is the demo that we're going to build out today. So I'm just going to return now to the presentation, and we'll walk through how we're actually going to build that demo in action. Okay, well, that's an introductory slide that I just skipped over. So let's talk a bit about the moving parts of the recommendation engine. Now, one of the things I want to stress here when we talk about these moving parts is, first of all, I'm going to present an abstract version of the moving parts, and then we'll talk about how these moving parts actually are realized in the SQL Server data mining model. Now, the first thing when you have a recommendation engine is to be aware of the historical data. That is to say, the data that you have about the customers and products that they've bought. This is the database that you've built up over the years of your customer information, in our case, say, customers and the movies that they bought. We pass this historical data to the data mining model, which creates a set of rules, what we call association rules, that says these are the items that are associated together in the basket, in the shopping basket. So this is our market basket analysis. These are the rules that we can derive from this historical data. Now when a user has some new data, for example, they've just selected a product, we can pass that information to the query processor, the data mining engine query processor, which then uses the association rules to recommend a new set of products. So it's really a very simple model here. Historical data creates rules, new data is brought in, the query processor uses the historical rules to recommend new products. When we see this in SQL Server 2005, then typically you're going to have a scenario where the historical data is stored in SQL Server. The association rules are built by SQL Server 2005 analysis services, which will also act as the query processor. The ASP.NET client that we're going to build is where we selected the product, and the recommendations, again, as you saw in the sample that I built, are sent back to the ASP.NET client. So it's really, again, a very simple model in SQL Server, which is going to reflect the very simple model that we're using to build this recommendation engine. Now, one of the features that's very useful for building a recommendation engine are the nested tables features of SQL Server 2005. Nested tables are useful when the data is actually much wider than an RDBMS can handle. If you can imagine all the possible movies in my movie database flattened out into a single huge wide row set, that would be much wider than the RDBMS could handle. And yet that's what I might need to do to build an effective model. When data is very sparse, it's also useful to use nested tables. Now when I say data is sparse, what I mean in this case is that most customers will not have bought all the movies in your movie database. You may well have 1 million movies in your database, or at least hundreds of thousands of movies in your database, and each customer has probably only bought a very small number of those. Even the most enthusiastic collector may only have bought hundreds out of a complete data set of thousands or hundreds of thousands even. So in this case, a nested table was useful as well, and we'll see why in a moment. Another thing that's important to point out here is that the semantic relationships between the data items should be useful. Now I can show this on the next page, but let me just briefly describe what I mean. By a semantic relationship, I mean that, for example, a customer 1 buying buying, say, The Godfather, is essentially the same semantic relationship as customer number 2 buying The Matrix. So the customers table and the nested table, the movies table, have essentially the same semantic relationship for every item that we're connecting. If we look at that on here, you can see that I have a customer table. I have customer ID, typical kind of customer data. I might have their gender, their marital status, their education, their home ownership status. I can add to that a table of the movies that they own. And you can see, of course, that in this case, as you might expect, there are relationships between the customer table and the movie table. So, for example, in this case, customer 1 has Lord of the Rings and also has Star Trek. And say customer 4 has Star Wars, and customer 4 also has Sixth Sense and A Beautiful Mind. Now, in this case, you can see that the semantic relationships between these tables are essentially the same. But of course, customer 1 doesn't have everything, and customer 4 doesn't have everything. They don't own all the movies in this table. So a nested table essentially says, let's take the movies table and nest it inside the customer table in such a way that we can query this using the data mining model, effectively embedding the nested table inside the customer table. Now, what we can do in this case is create what I would call a self-nested table. That is to say, when I'm considering whether customers buy movies or not, one of the most important things to input is the movies that customers bought. In other words, we're using the fact that customers bought movies to predict the movies that a customer might buy. So the movie table is both an input table and, if you like, the prediction table as well, the output table. And so we can call that like a self-nested table. Now, one thing to notice is that the self-nested table that I've built here has customer ID and movies, and I've taken out all that demographic information I had previously. If you remember, I had all that stuff like whether they're a homeowner or not. Think back to what I said about the recommendation engines, and that I said that they were driven primarily by the customer behavior, not by anything else. So what I'm saying here is it's not important whether somebody is a homeowner that they bought Lord of the Rings or Star Trek. It's important that they like Lord of the Rings or they like Star Trek. That's the factors that we're using here. So all we're really interested in here is the customer and the movies that they bought. So with that, I think it's time to talk about how we prepare the data for this scenario so that we can get started building our recommendation engine. So once again, I'm going to drop out to a demo. And in this case, we're going to use the Business Intelligence Development Studio, which is the development environment for SQL Server 2005 Business Intelligence. I'm going to create a new project here, and the project is going to be an Analysis Services project. When I select Analysis Services project, I don't need to select specifically that it's a data mining project. I'm simply going to select Analysis Services project. And the first thing I need to do is to create a data source. How am I actually going to connect to the data? Now, the data source in this case is going to be in SQL Server 2005. So let me go here. It's in my Scratchpad database, which is just a simple database I use for samples. I'm going to use the default credentials for impersonating, and I'm just going to call this the Scratchpad data source. That's fine. So that's created a data source which knows how to connect to the underlying system. Now what I'd like to do is create a data source view, and when I create a data source view, I again choose the data source, and in this case I have to choose the table that's available. I have a customer movies training table. I'll select that. It's the only table I have in this case, but there may be several others. And again, I can just call this customer movies. Now, a data source view essentially is a metadata view of the data that I've just selected on my data source. I can do a number of things with the data source view, such as explore the data. And when I explore the data, I'll get either a visualization or just a table view of all the data. So I can see here, for example, a customer ID and all the movies that customers bought. I can also chart this if I needed to. But in this case, I've created a data source view of customer movies, and that's been particularly useful for me here because now I've got the customer ID and the movies they bought in a single table, and that's what I'm going to use when I come to build the data mining model in a moment. So let's talk a little about how we build that data mining model. And the first thing we're going to talk about is essentially the association rules. Now, I'm building what we call an association model because I'm interested in how the different items that people have bought are associated together. So in this case, when I build the association model, I'm going to use the association rules algorithm. It learns the items which are bought together, and it creates rules which enable me to predict new items of interest based on that association. I need to specify how the different columns are used by the algorithm. For example, I need to be able to say what are the keys in this case, and what are the inputs, and what are the predictable columns. And you'll remember that what I said was that input columns, in this case, are going to be the movies, but the predictable columns are also going to be movies. So you'll see how I construct that in the wizard in a moment. And we're going to be using a self-nested table in this case, because input and predictable are going to be the same. So it's going to be fairly straightforward to build this model, not a difficult model to build at all. And the association rules algorithm is one of the, in some ways, the easiest algorithms to use when you're learning, because it gives a really useful guide to the user. It's quite easy to understand the results from it. So what we'll do is go back to the demo, and we'll build the association model, and we'll talk through various aspects of what the association model is doing as we walk through that. So back to the application, and in this case, I have the customer movie DSV here, and now I need to build a data mining structure. So I'm going to say new data mining structure, and there's a wizard which will walk me back through this process. I'm going to build this based on an existing relational database, in fact, just on one single table. And I'm going to choose the association rules algorithm. Now you'll see that there's 9 algorithms here. In this case, we're going to use association rules because it's the best rule to use for market basket analysis. At the end, we'll talk a bit about a little bit about the different algorithms, or at least how to find more resources on which algorithms to choose. But in this case, association rules is what we want to use. The available data source view is very simple. I've got movies, and that's straightforward enough. Now, remember that I said I was going to be using a self-nested table. So the cases that I'm going to train against are the customer movies, but that's also going to be the nested table within that. Now I get to the point where I choose those predictive and input columns. Movie is what we want to predict, so I'm going to select to predict the movie. But movie is also the input, so I'm going to select movie as the input. As it happens, movie is also the key which joins the nested table to the parent table, and customer ID is the key of the parent table. So I'm going to say customer ID is the unique key of the parent table, and the child table, which is the parent table as well in this case because it's self-nested, is going to use movies as input, and it's going to predict movies as the output. I have a choice to specify the content and data type, but in this case we know that the data type is text for the movie, and the customer ID is an integer. And now I get to give the mining structure a name, and I'm just going to call it customer movies in this case. And so here's my mining structure named. I can click finish, and at that point I've created the basic mining structure that I'm going to use in my analysis. Now there's a couple of things I want to do here just before I move on. And one is probably going to rename the columns at some point. So let me go in here and rename the project at some point. So I'm just going to go in here and rename this project as customer movies, just to make that a bit tidier, and change the object name, which changes the underlying object, not just the name of the object, and rename the solution as well as customer movies. Okay, so in this case I now have my solution built. Very simple association model. Let's go back to the presentation and talk through some of the next steps that we want to do. Now, having built the association model, one of the next things we have to do is to deploy the model and train it. Now, deploying the model is actually fairly straightforward. We need to set the server properties so we know what server we're sending the model to. And when we select to deploy the model, the metadata of those objects that we've built, the association rules model, the data source view, and the data source will be sent to the server. And immediately we send those to the server is going to start to train the mining model. Now what training the mining model means, it's called processing when you see it in the UI, is it's going to read the data from the data source through the data source view, and it's going to start to analyze that data to find the association rules that we're talking about. So it's going to apply the algorithm to the training data. It's going to discover those association rules and prepare them in such a way that they can be used to perform predictions. When you want to retrain the data with new information, for example, you get some new customer data in, maybe at the end of the month you want to retrain it and take account of trends and changes in your customer data, then you can schedule or automate the retraining of models. You can even call it from within an integration services package. So you can have a package which went out, got your customer data, got it into the form you want, loaded into your customer database, and at that point you'd be able to automate or schedule the retraining of the model. And typically you'll probably want to kind of automate and reschedule the training of the model fairly often, especially if you're in a scenario where customer trends are causing that data to change over time, because you don't want to have an out-of-date or, if you like, an old-fashioned set of association rules being applied to constantly changing customer behavior. So with that, let's have a look at another demo to see the training and testing of the model in action. Now in this case, let's just get back to the demo scenario. And remember that you can press F5 to see this in full screen if you have problems seeing all the various parts of the different parts of the screen, because I realize that there are several panes in this screen that might be a little bit difficult to see if you have a low resolution. So in this case, with the mining model created, the first thing I need to do is make sure that the server for the project is set correctly for deployment. So what I'm going to go in here is just look at the project properties and check the deployment tab, and I can see that the server is localhost, which is fine in my case. And I want to make sure that the database it's being deployed to is called Customer Movies. So now I have, I'm going to deploy this to an analysis server database called Customer Movies. Now there's one other thing I need to do in this case, which is I need to add a role which will enable my ASP.NET users to have access to the data mining model that I've built. So in the case of roles, I'm going to give myself a new role within the analysis services database. It's going to be a read-only role because it doesn't need to write to the database. It's just going to use the database to query the mining models. Membership in this case is going to be for the ASP.NET group within my local machine. So I add ASP.NET as a user group, and then I can go to the mining structures and just make sure that I've actually given them read definition to the movies, which I have here. So at this point, I'm now ready to deploy my model. I'm just going to save these changes that I made, and now I'm ready to deploy the model. And when I deploy it, it's going to process this as well. So when I call deploy, you'll see that deployment progress is shown. We send the meta to this data to the server, and if I was to look down here, I can see the processing taking part as well, and I could even look at the various queries that were being issued to do the processing. So I can see how the data is being selected from the data source and trained against the model. Now at this point, then, I've used the algorithm to train a data mining model, and I can now go in and start to explore this data mining model in a little bit more detail and start to understand what it takes to perform the predictions of these movies. So in this case, I can see that I've got the mining model created with the predicted column, which is Customer Movies, and key there. So let's look at the mining model viewer, and the mining model viewer is going to allow me to view the association rules that have been discovered. Now the first thing that we're going to see on the left-hand side here is called item sets. Item sets are simply the items that were found in the customer databases. And you can see that the most popular item found here was Star Wars. So we call this value the support. Star Wars has a high level of support within that within the case tables. So Star Wars is the most popular, The Matrix next, and A Beautiful Mind is the next most popular. So that's just a very simple measure, as you say, of the support of the items within the data set. The next thing to look at, though, is the rules, and the rules are really pretty interesting. So let's have a look at the Rules tab, load the rules that we'll find, and in this case we're going to see some additional metadata. I think the first thing to look at is the probability. The probability of a rule is sometimes called the confidence. It's really the probability that this rule is going to be found within your data set. So the simple rule at the top that we can have a look at here is that, let me just close this pane to make it a bit wider, that if somebody has The Godfather Part 3 and The Godfather Part 2, then they will have The Godfather. And that's the first rule. There's another rule that says if they have Star Wars Episode 1, Phantom Menace, and they have The Return of the Jedi, then there's a good chance they're going to have The Empire Strikes Back. And these are the rules that have been discovered within the system. Now, there's probability and there's also importance. Importance is really how significant it is that that rule predicts the final outcome. So, for example, there are probably several rules which can suggest that The Godfather may be owned by somebody. But of all those rules, The Godfather Part 3 and The Godfather Part 2 have an importance of a relative importance of 1.089 that they refer to The Godfather. So, for example, if we sort by these rules here, I can see that there's a couple of rules here that suggest, for example, that if I have Indiana Jones and the Last Crusade, that is a very important rule for showing that Indiana Jones and the Temple of Doom is also owned. Indiana Jones and the Last Crusade is a less important rule for showing that Raiders of the Lost Ark is owned. Okay, so it's got greater importance for one outcome than for the other. We can also see these rules and models in what's called a dependency network, which is the graphical way of looking at the same results. In this case, we can see a nice graphical view of the relationships between different items. Let's go back and have a look at the Godfather trilogy in the corner here. I'm going to just move in here, and you can see that in this case, let's select Godfather. And if you look at the coloring at the bottom, Godfather is a selected node. It predicts The Godfather Part 3, and The Godfather Part 2, in fact, predicts both ways. Predicts both The Godfather and is predicted by The Godfather. I can move the links and remove the strongest links, the weakest links, sorry, until I'm left with only the strongest links that are important. In this case, I can see that The Godfather predicts that somebody will own The Godfather 2 is the strongest link. And as I move up in the slider, I can see that eventually The Godfather Part 2 may also predict that somebody owns The Godfather. And then finally, this pops in as another important rule, but somewhat less important than the others. So in this way, I can start to understand all the relationships between my items and get a good visual sense of how all these things are related. You can also think about the importance rule here as being, if you like, the interestingness of the rule for finding a particular item within the record set. So with that, having created the model, deployed the model, and explored the model a little bit and understood the relationships between the different elements of the model, let's go back and now talk about how we connect to this model from a recommendation client. So let's go back to the presentation. And in this case, let's talk about how we query this model in order to understand, in order to pass in movies that people have bought and get back information about movies that they may be interested in. Now, the mining model, as we said, uses a nested table. So the input to the query is, in fact, itself a nested table. And you can see that here where we have essentially nested these two movies union together as a table inside the join that we're querying about. Now, when we do that, another thing that we want to do is use the union operator to add all these separate movies as a single row inside the prediction join clause. Now, what we also have is that all we're passing in this case is movies. You'll notice that we're not passing in the customer ID, because who the customer is isn't actually important to our prediction. It's only the movies they bought that's important to the prediction. Again, this goes back to the fact that we're interested in modeling their behavior as it relates to movies, not to anything else, the simple form of market basket analysis. So we're not passing in customer ID or anything like that. Another thing that we're doing that might be interesting is that we're passing in, we're asking for the top count of movies, and you can see that we're asking for the 3 top movies in this case. Here, we're asking for the 3 top movies. And we're also asking for them to be ordered by the adjusted probability. Remember that probability was this measure of how likely the rule is to be found in the database. So what we're saying is, show us the 3 top movies, and show us those 3 top movies based on adjusted probability, and return those 3 top movies based on the movies that we're going to be passing in. The natural prediction join that we're talking about here, we don't need to worry about too much, but that simply means that the columns that we're passing in are just going to be matched by name to the columns in the data mining model. So just to summarize then what we saw in the MDX, the mining model uses a nested table, so we're nesting the cases in the DMX statement, this data mining query that we're sending. The nested subselect is that subselect after the natural prediction cause. We use the union operator to add each movie as a separate row, and then we don't supply a customer key because it's not needed for the prediction. One other thing you may have noticed was that we had the flattened keyword. We said select flattened top count. The reason we ask for a flattened top count is that otherwise we would get back a hierarchical structure that frankly would just be a little bit more difficult to navigate in the simple ASP.NET web client that we're building. So we don't want a hierarchical result set. We're just going to get a flattened result set, which is easier to query or easier to parse when we get back to the .NET client. Now, when we come to create the client form, that form that we showed at the beginning, it's really pretty straightforward. We can use string templates for the DMX query. So we just build a template query based on that one that I've just shown you. Then all we need to do is iterate over the items that the user selected when they enter that in their form. And then I need to send the data to the analysis server as a query, send this to this query I've constructed, and then get back the query results. I'm going to use ADOMD.NET to connect to the server. That's the connection classes for analysis server, the managed connection classes. So I need to add a reference to that to my web project. And when I query the results, I can just use a standard ADO.NET data reader interface to get those query results back. Again, that's one of the advantages of getting the query results back as a flattened row set. So it's really fairly straightforward to do that. Let's have a look and start to build a recommendation client. Now, one thing I want to emphasize here is that the recommendation client we're building is built in the Web Developer Express Edition, but you could just as easily be building it, as I say, in other editions of Web Developer or in C# or Visual Basic or whatever your development environment of choice is. So we're not particularly limited to that. It just happens to be the scenario that I'm using. So with that, let's go back to the application sharing page, and I'm going to go back now here to my web recommender, and this is the project that I built in my Visual Web Developer Express Edition. Now you can see that it's a very simple project. I have a simple label at the top that says this is a web recommender page. I have a text input box. I have a button which is going to perform the action of adding items to the shopping cart and creating the query and sending that query off to SQL Server. And then I have a way of showing the items which are in the cart, a little item that says customers who bought this movie also bought. And you know what I'm going to do here is I realized when I was just showing my first sample that in fact it's not so much customers who bought this movie. You might want just to say customers who liked this movie, because there is a little twist to this that I'm going to show you later on, which is not just about recommending based on what people buy, but also on what people like. So I could perhaps change this to say customers who liked this movie also liked. And then at the bottom we've got a grid to give the results set. So it's a very, very simple form at least, but let's see some of the code that's behind it. So what I'd like to do now is just open up the Visual Basic code that's behind the Web Recommender form, and let's start looking at some of that. So remember then that the interesting thing was to use string templates to create those queries. So what I'm going to show you here is the first string template, and as you can see, basically what I've got is an outline of the query that we created, and that query then has some embeddable strings, string DMX2, which I can insert the movies that were selected by the user. Now to get the movies that were selected by the user, all I need to do here is to iterate through the shopping basket and look for items, and then add those items to the string using that select clause, that sub-select clause, and the union. So if they select more than one item, I can union those items together and put them in as that sub-select clause for the DMX prediction join statement. At the end of that process, having iterated through the shopping basket, all I need to do is concatenate all these together, and now I have a DMX prediction query that I'm ready to send to the server. In order to send it to the server, I need to connect to the analysis server to execute the query. So I create this analysis services session object, and I'll show you that at the bottom of the session. Connect to that and execute and fetch the results, passing in the query string. Now all I have to do is parse through the prediction results, just like any other ADO.NET data reader. Parse through those results and write them out into the grid view, this view of the recommended items. And so it's really very straightforward. Once I've got the query, the parameterized query, I construct this dynamic string using the items that I've parsed from the user's input, send that to the analysis server, get the results back as a data reader, step through the data reader, and put those results into the recommendation pane at the bottom. The analysis server is then cleaned up. This is all driven by a get recommendations subroutine, which is built, which is called from the button click, and the button click simply makes sure that we can parse out items which are delimited with a semicolon from the customer input, and then calls the get top 3 recommendations, and finally displays the recommendations at the end. The analysis services session object that I described is built here, protected. We simply connect to a local host and customer movies as the catalog. You want to make sure that this, of course, is coded to the database that you've already built. You probably want, in some cases, to parameterize these connection strings so that you can redirect them easily to different servers and potentially even to different databases if you need to. Now, having just stepped through the code of the client to say this isn't a webcast about how to build ASP.NET code, but it does give you an idea of how relatively easy it is to connect to this data mining query. Let's run this recommendation engine again. Pop up an example, and what I'd like to do in this case is enter some examples and then compare this back to the cases that we were talking about earlier, the rules that we were talking about in our engine. So having done that, let's ask for a recommendation. In this case, let's ask for a recommendation if I like the movie Alien. So I'm going to add the item to the cart. We'll construct a query, send that off to Web Recommender. And in this case, I seem to have a slight problem. Let me have a look here. I've got a problem in the prediction function. Let me just close this one and use this one earlier. And see if I still have a problem. I think the problem may be that I didn't deploy the original project properly. So what I'm going to go do is just go back into my management studio, make sure I actually have the correct tables here. I have customer movies. Here's my mining structure, customer movies, a mining model, also called customer movies, and let's have a look at this one here, customer movies A. I just want to compare the one that I've already constructed to the one that I had earlier. It looks pretty similar. Do you know what I'm going to do in this case, though, is I may have done a slight problem when I was walking through that demo, so I'm going to cheat ever so slightly and just rename this one to be Customer Movies A. Those of you who are watching from the UK will be familiar with the phrase from the UK children's program Blue Peter. Here's one I built earlier, which they always used as a way of getting around similar problems. Let's try this again. This point, yeah. So in this case, it was simply a problem. I must have made some mistake when I was building the model. Perhaps I named the column incorrectly. I apologize for that. However, in this case, you can see what we've got. I passed in alien, and I returned alien, and you can see that the rules I've got, the rules have returned that if I'm interested in alien, then I'm also likely to be interested in Aliens, Star Wars, and the Matrix. I can go back and look at the rules that I had to show that in action. And you'll see that indeed, if I was interested in alien, that the rules suggest that I will also be interested in aliens. Okay, so I'm interested in aliens, I'll also be interested in aliens. Now, why then does it also recommend Star Wars and the Matrix? Well, one of the things I mentioned a little bit earlier was that I may be interested not just in, I should probably rename that label to say it's not just customers who bought, but customers who are interested in. I've only got one rule here that tells me what people will be interested in if they bought Alien. It says that if they bought Alien, they may also buy Aliens, based on a historical data set. But if I go back to my item sets, you can see that Star Wars and the Matrix were the most popular items. So what the prediction rule is saying is, if I've got a rule, let's return the results based on that rule. And then if I don't have enough rules to make up the top 3 items, return the 2 most popular items in the data set, because they're likely also to be interesting because everybody likes them. They're the most popular. So my web recommender has, based on that rule, has returned Aliens as based on the rule, and Star Wars and the Matrix based on the support in the item set. Let's try one other scenario here, and let's try The Godfather, and see what we get when we do this. Again, add the item to the cart, and it says that The Godfather Part 2 is interesting, and again, Star Wars and the Matrix based on the support in the item set. Again, let's go back to the rules and see what we get from that. And if I go back to The Godfather, here, you'll see that indeed The Godfather, there's only one rule which says that if you have The Godfather, you may be interested in The Godfather Part 2, and that's the rule that we use to generate those results. Look at this, however, if I choose The Godfather Part 2, there's a rule which says that I may be interested in The Godfather, and a rule which says I may be interested in Godfather Part 3. I can demonstrate that in action by simply saying The Godfather Part 2 is what I'm interested in, and you can see that indeed it says The Godfather Part 3 from the rule, The Godfather Part 2 from the rule, and those are the 2 rules I processed, and the 3rd item that I've asked for comes from the most popular item in the item set. So my web recommendation engine is driven by the customer behavior, both in terms of the rules that we're using to derive these recommendations, and then if there's no particular rule, let's take the most popular items from the data set because they are also going to be most popular. So you can imagine in a bookstore, we might go in and say, okay, there's a rule which links Chinese cookbooks, there's a rule for data warehousing books, and if we can't recommend anything else, we'll just recommend today's bestseller because everybody else seems to like that too. So you'll always get some useful information from the web recommendation engine. So with that, let's go back and have a quick summary of what we've seen to date so far. First of all, I want to just summarize that the recommendation engine that we've shown is really a very powerful tool. Although I've shown you a very simple case, you can imagine that there are more sophisticated capabilities that could be built. I've shown you a case which is only based on customer behavior, simply based on what customers have been buying. It would certainly be possible to build a more complex model and a more complex engine which did take into account other things you may know about your customer, such as their demographic background, their age, their gender, their income, and so on. So you might be able to build something which derived those rules as well. But the very simple engine is actually still very, very effective. And the recommendation engine can be called from an ASP.NET client, which I think you can see is actually pretty easy to build. This is not a complex process, querying this engine. In fact, it's a very powerful capability in a remarkably simple code and a remarkably simple model to build. I hope you found this pretty interesting. I want to just point you to some important websites that you might be interested in. The first website that on my list is SQLServerDataMining.com, and I highly recommend this as a website with resources and tutorials and articles. I certainly in particular recommend that you look at the articles that can be downloaded, and there you will find the original article by Roman Iyer and Jesper Lind about how to write a web recommendation engine that this webcast has been based on. And that includes code and samples that you can download and a step-by-step kind of code guide to how to build this, this recommendation engine that I have shown. You should also look perhaps at the Microsoft.com BI site, where there's some excellent business and technical decision maker material on the data mining capabilities of SQL Server. Also look at the Technologies website for SQL Server, which gives you a lot more technical detail on what algorithms are available, what models you can build, and so on for the for SQL Server data mining. Finally, if you've got questions, not just questions about this webcast, but in general questions about data mining, or if you run into any problems building any of the samples, or if you just get into data mining to the extent that you want to ask us more questions, there is a great data mining forum. And if you get onto that on the Msdn forums, you'll find that there's a really lively community of users who are helping each other and also asking questions of the Microsoft team. Of course, you can also contact me, Donald Farmer at Microsoft.com, and anything I can't answer, I'll certainly pass on to others. I'm always very happy to get mails, whether they are about technical issues or customer issues or any of those other things. There's an excellent book on data mining, which also includes some information about how to build recommendation engines and other business scenarios. The book is Data Mining with SQL Server 2005 by Jalwi Tang and Jamie McLennan, and it's a Wiley book. And I've included the link here for you to get to that book and start perhaps be able to learn some more information about the background to SQL Server data mining and get into some real technical detail. With that, I'm very happy to look through the questions and answers, and I'll have a look at that. And while I'm answering the questions, the text questions, verbally, please don't forget to fill out the survey and to look for any of the upcoming webcasts that we have.
All right. Thanks so much, Donald. And as Donald mentioned, he will be answering the question and answers verbally here in just a minute. So if you have any last-minute questions, go ahead and type those in now. As I mentioned, if you have more than one question for him, go ahead and just type in one. Once he answers it, you can go ahead and type in the second one. And we'll also be providing a survey here in just a minute. And to print a copy of today's webcast PowerPoint, just simply go up to File and click on Print to PDF. And to view a replay of today's live event or to register for upcoming webcasts, please visit Microsoft.com/webcast. And by attending this live webcast and by simply filling out the evaluation, you are registered to win the Zune Digital Media Player, which is now shown on the screen. And it is legit. I actually talked to someone the other day who had won one. So all you need to do is fill out that evaluation, and you will be put into the pot to win that. And bear with me 1 second while I go ahead and get that survey up there. And it'll just take about a minute, maybe 2 minutes tops to fill that out. So go ahead and fill out the evaluation, type any last-minute questions for Donald, and I'm going to go ahead and hand it back to Donald to start answering your questions.
Great, thanks very much. And so we've got a number of questions here. I think probably the most common question I'm seeing in the question manager is just where can we get the source and the slides. The slides can be printed out, I think, from the webcast, and the webcast can be viewed in a recording. And if you need to source for the webcast, the best place to get that is to go to SQLServerDataMining.com, and you may need to sign up there. There's a very simple kind of free sign-in, which just allows us to understand what users are looking for on there. And from there, go to the tutorials and articles, and under articles, you'll find an excellent article on the ASP ASP.NET Pro site, I believe it is, but there's a link on SQL Server data mining to the original article by Roman Iyer and Jesper Lind, which walks through this example I've shown you with downloadable code, even a downloadable data set that you can use for this example. So you'll find all the code and a very detailed step-by-step article there at SQLServerDataMining.com. The SQL Server data mining site is www.SQLServerDataMining.com. You should be able to find that fairly straightforward. One question I had, which is quite interesting, is can we disable the also include most popular functionality? If you remember, one of the rules I showed was that we made some decisions based on the rules, and then when we couldn't answer a question based on the rule, we went and chose the most popular items from the data set. It is possible to ask a much stricter query. It's a more complex query, and I can't remember off the hand what syntax you use, but there's a couple of different parameters. I was querying using adjusted probability as the metadata by which I was going to sort and select my result set. But there are a number of other options that are available there. If somebody wants to contact me offline, I can probably answer that question in more detail when I have the technical documentation to hand. But it's certainly possible once you get into data mining a bit more to ask more sophisticated queries. But I'm sure you understand that for the scenario I was building here, it was simple just to show a very simple query. In fact, many people find that functionality of returning the most popular result actually quite useful as well, because it means that in almost all circumstances you can actually create some recommendation. And many online web recommendations actually use a similar system, of course. Somebody asked about the front-end tools that we can use for browsing the miner model viewer rather than the website. And yes, you can, in fact, use other tools. And it's possible to browse mining models now using the data mining add-ins for Office 2007. These are freely available add-ins that you can get from the Microsoft.com download sites. There's also links to it from SQLServerDataMining.com or from any of the Msdn data mining sites. And these add-ins include the ability to browse mining models. They also include a Visio interface which allows you to document mining models quite usefully. It's also very possible to, if you're a bit more advanced or a bit more adventurous, to write your own mining model viewers, because we expose all the metadata that's required for browsing mining models to the end user, so you can query the data mining model and build your own viewer. And there are also thin client viewers, embeddable web parts, which enable you to browse mining models. Again, they can also be downloaded, and there's quite a lot of documentation on how to use them in books online. There was some question about whether there are drivers for anything besides .NET. In this case, you can also use XMLA, which is a SOAP-based protocol for querying analysis services, and it can be used to pass DMX queries also to the analysis server. So it's possible in this case to query from, say, from a Java interface or from some non-Microsoft client if necessary, using XMLA as the interface for doing that. And again, XMLA is pretty fully covered in the documentation of books online, and is a well-supported standard. But it is also SOAP-based, so it's pretty easy to use from other clients. I think that covers the questions that we have here. The other questions, again, were around things like the the download sites and so on, and they are included in the text of the webcast. I think one of the final things I want to suggest to people is that what I've really done here is show a very, very simple scenario. But I think it's interesting, and I certainly haven't covered all the bases. There are ways in which you can both widen the scope of this scenario to include customer background information that may also be relevant to their choices. It's also possible to narrow the scope by looking at scenarios where you're trying to find association rules, which, for example, are much stricter than the ones that I've been showing here. In an e-commerce environment, we're talking about something fairly relaxed. So I think that's kind of wraps up with the questions here just now. I'm really happy to take further questions offline at donald.farmer@microsoft.com, and we can drill into that, any questions that you have in more detail. But I'd like to thank you for attending the webcast. I hope you found it interesting and enjoyable, and I hope that you'll be able to go out and at the very least get started with using data mining and perhaps build a recommendation engine of your own on your own websites. Thank you very much.
All right, and thank you again, Donald. That was a fabulous webcast. Thanks for everyone for attending. And as Donald mentioned, feel free to email him. And that concludes the audio portion for today's webcast. You may now disconnect.